Welcome to In the Loop, a New England Temperature Solutions podcast. In today's episode, NET's President Dominick DeLuca will be sitting down for the second time with Cory Watkins, President of Control Concepts, on location in Chanhassen, Minnesota. They'll take you on a deep dive into SCR power controllers and the significant energy and cost savings they can bring to your process. Without further ado, here's Dom and Cory helping you get in the loop.
Hi, welcome to In the Loop. I'm here with Cory Watkins, President of Control Concepts in lovely Chanhassen, Minnesota today. And this podcast is going to be on green technologies, green initiatives. What questions do you get asked about the environmental impact or how to reduce energy using SCR power controllers?
Yeah, the question I've gotten most has been, how do we improve the efficiency of our SCR power controllers? And great question. I guess I can elaborate the answer, because the answer really is you're asking the wrong question.
Okay.
But we'll first go back to the first one. SCR power controllers turns out are very, very efficient. They're typically, if you're running above 120 volts for line voltage coming in, you're looking at anywhere from 98.5 to 99.7% efficiency. So we're talking about electrical power coming in versus electrical power going to your load.
Right.
So it's very, very high.
Okay.
And they don't want to hear that, because the reality is, that means that there's something else going on, right?
Right.
So that's the first thing I tell them, is that it's not typically a power control problem, but it is a process problem. So what I tell them is I can't help you improve the actual efficiency of the SCR, but I can help you and discuss how to improve your process, right? And that starts with, you have to have information. And so typically I say, first off, you got to know how much power you're using. That means you need to have a digital power controller that you can get the information back from the power controller. So our power controllers, our microfusion series, are instrument grade power controllers with instrument grade power meters built in. So we monitor line voltage, load current, real power, and I'm talking true RMS real power, and we can do power factor. And then we also monitor kilowatt hours used.
Okay.
And so one of the things you can do on our power controllers, you can hit the reset button at the beginning of your process, run your temperature profile and your process step. At the end of the batch, you can go and read that number. It'll tell you how many kilowatt hours did that power controller use.
Oh.
So it's pretty interesting. Mm-hmm. But really, when it gets into how do I improve my power efficiency of my process, you have to really look at the heat analysis of your furnace and chambers. You're looking at input power versus heat losses. So how much is going up a smokestack? How much is going radiative losses out of the furnace and oven? Are there things that you can do to improve that? What is the cycle time? Do you need to dwell for so long at that certain temperature? So really, it's really going in and digging into your process, analyzing it, understanding the heat calculations. It might be adding chamber interlocks to be able to prevent cold air rushing into your furnace. It could be shortening the cycle times. So yeah.
Well, the whole idea of an SCR of phase angle fired anyway, where you're actually controlling at a different power level to maintain a temperature, has got to be energy efficient, because you're not overheating, cooling.
Correct. Yeah. So yeah, just using an SCR alone helps and improves over, say, a contactor.
Right.
Right, because you're not going to be overshooting and undershooting as much. You're going to be more steady state.
Yeah, because I know that using that, it actually extends the life of a lot of heaters, because they're not getting hot and cold, and that's changing the process variable. Okay, keep going.
So other questions. The other question we get is about, we'll say, power factor and harmonics.
Okay.
And so we talked a little bit about this in our first segment. To address power factor, I would say the best thing to do is to look at whether or not you can run in zero cross mode. If you can run in zero cross mode, we have a couple of different zero cross modes. We have, we call it normal mode, and then we have what is called fast zero cross. And it just has to do with the different time periods, but it's basically passing different half cycles through. That allows you to maintain basically unity power factor from the perspective of the power controller. Now, your plant still might have a bad power factor at the pole, but as far as our power controller, we're not adding or being negative in your plant and reducing it. So certainly going zero cross helps. When you're looking at phase angle, now you're dealing with more power factor. You really have to look at the percentage of phase angle load that you have in your factory as a percentage of your total load of your factory to see what type of impact it's going to run. And then also, am I running at, we call it high conduction angles, or, the worst case operating phase angle for a power controller is right at 50% output. Right? So if you're right at the 50% mark, there are some things you can do. You could change your line voltage. That would, if you reduce your line voltage, that would up your phase angle output. That would improve your power factor. So there are some tricks that you can do that way too. So, and then the third that we see has to do with the IEEE 519, just kind of harmonic specs. Again, going back to zero cross, whenever you can run zero cross, we recommend that you do run zero cross. But sometimes, your process doesn't permit that. You have transformer coupled loads. You're going to want to run phase angle. And then you're going to need to basically do potentially pole studies, or put there's a fluke meter that allows you to do power quality analysis right at the entrance of your facility power. And that it can give you kind of a pass-fail for IEEE 519. So. Yep.
Okay. And then compared to IGBTs?
Yep. Yeah, so, we talked a little bit about the efficiency of the SCRs. IGBTs typically are ranging from, I would say, about 83% efficient to about 92% efficient. Newer silicon carbide, you can get up into the 96% efficient. But the reality is they're all doing basically double conversion. And that's doubling the amount of heat. It takes up more panel space. It costs more and less efficient. So, so far, and we've been searching. The SCR is still the best way to switch simple AC power. So.
And then compared to gas?
The good news is that with an SCR power controller, you can take advantage of renewable energy. So we can take advantage of wind power. We can take advantage of solar power when you go electric. Now, I will say this: the gas is still pretty cheap here in the U.S. And so it's still going to beat out a lot of processes when just on pure cost. But if you are in a situation where your facility does need to go green, SCR is a great way to go. Electric furnace, SCRs can take advantage of the green power. So.
Yeah, years ago we converted everything from electric to gas, and now there seems to be a movement to convert it back to electricity. Now I don't know whether that's been sidetracked with recent events, but
yeah, it's we saw a few more inquiries a couple years back as far as going green and going electric. They definitely were looking at converting some gas ovens to electric. And I actually anticipate that we will see that again. We're poised to serve that market well. So.
Okay. Anything else?
That's about
it.
it.
That's it. Okay.
Short and sweet.
Short and sweet. All right. So use an SCR and you'll be good. So thank you, Cory.
Thank you, Don.
Thank you for watching, and please, if you have any questions, feel free to email me. Contact information is associated with this podcast, and I'd be happy to get your questions answered. Have a great day. Thank you. Bye-bye.
Thank you for getting in the loop with us. We hope this podcast has been informative, and if you need assistance with anything in the thermal process industry, please feel free to reach out to us at 800-848-NETS. That's 800-848-6387, Or you can find our contact information on our website at www.nets-inc.com. If there are any topics you would like to hear about on a future episode, please send us a comment. The team at Nets is here to help, and we hope you have an awesome day every day.